here. Group 1 has this structure. Group 2 has only this structure. See the difference now? It is resonance stabilized. It has just dispersed on one oxygen. That's the difference between group 1 and 2. Now you see the chemical environment completely changed. Good? Okay. Now rank 1, 2, and 3 from lowest ppm to highest ppm. When did you learn it? Mitali, I'm coming from the meeting. I'm coming from the did you get an email? If your class size is less than 100. I'm coming from the meeting right now. I don't know, maybe right now what they said, but I was in the meeting till 1 o'clock. And to my information, if the class size is less than 100, then it is 100%. And that too, you must be vaccinated. Yeah. Yeah, because and another thing is all the teachers and the students who wish to attend in person should be vaccinated also. Yep, there is not an easy joke, like it's going to be tough for everybody. Yeah. So I'm just telling you that. Yeah, because I was in meeting till 1 o'clock, and in the meeting I heard that we all the recitations probably will go in person, but only the students and the instructors who have get vaccinated by that time probably will be allowed. And if you're not comfortable to get vaccinated right now, then you have to go online or something. There's lot of things going to come. Don't worry about it. Just wait and watch is the answer. Yeah, we do not know how long we have to be here. No. I know. Let's start. Let's wait and watch. 2, 3, 1. Okay. Do you remember this number I told you in the class 9 to 10 ppm? Most downfield because of ring current. So 3 is, okay, you said lowest to highest. 1 is less than, 2 is less than 3. Because this is CH3 and this is CH2. So 1 is less than, 2 is less than 3. Everybody getting the chemical shifts? Anybody has any question on chemical shift should speak. Otherwise, we are going to go to the next question. No, downfield. Highest number downfield, lowest number. Downfield mean down to the reference point, right? So higher number means downfield, lower number is upfield. Yeah, sure. Aldehydic protons
as the highest because it was a CH and it was connected to an electronegative oxygen.
Now this has a this has a resonance. You know that this is a resonance stabilized ion. So there's a ring current of pi electron density because of which this aldehydic hydrogen goes. It has both effect, resonance and induction. Induction means because of oxygen, right? So because of it, this goes highly downfield, and the downfield is 9 to 10 ppm. And then I saw there is a CH2 here with 2 chloros. So I said CH2 is already downfield than that of CH3. So this will be the highest. This will be the second. And this will be the third. And my question was lowest to highest ppm. So I say 3 will be, this is 1. and this was 2, and this was 3. So 3 will be the highest ppm and 1 will be the lowest. That's right. Halogens, okay. Any proton closer to the electronegative groups like oxygen, nitrogen, chlorine, bromine, they always go downfield, and their numbers come up somewhere around 3 to 5, some in this range, 3.5 to 4.5 approximately. More the electronegative group, more downfield, right? Less electronegative group, less downfield. Resonance, because of the ring currents, I told you, explained you in the class that the magnetic field, because of the pi electron density, the magnetic field created by the pi electrons goes in the same, goes in alignment with that of the applied magnetic field. So when they get aligned to the magnetic field, they the electron density, they decrease the electron density. So they decrease the electron density around the proton. That means the proton is getting deshielded now. And when it is deshielded, obviously it's become higher in number. That is why aldehydes and carboxylic acids always have a higher number because of two factors together. One is ring current. Ring current means pi electron density localization, magnetic field obtained by the localized pi electrons, right? And in these case, in case of alkenes, in case of aldehydes, these ring currents are always start oscillating in the same field as that of the applied magnetic field. Basically, they go and add up to the applied magnetic field. Think about that. If a proton is being in an applied field and the applied field is reinforced, so what will happen? That means it is not being shielded shielded correctly by, or more by the electron density. The electron density is going away from the proton, and that proton get exposed to the magnetic field more, and that's why the spin, alpha and beta spin, has more difference. And if alpha beta spins have more difference, frequency required to resonate is also more, and the number becomes higher. Okay, everybody good with this concept logic? Yes. Now next is write the multiplicity of protons of non-equivalent protons in each of the following cases. Multiplicity. Now I'm picking up some from the previous one. Let's take up, yes, we can do the second. I'll do one with you all, and then you will do few all on your own, right? What is multiplicity? Multiplicity is because of spin-spin coupling. How it depends upon number of neighboring protons. So 3J coupling only, we are talking only about 3J coupling, that is 3-bond coupling. The equivalent protons on the adjacent carbon gives n plus 1 peak splits the peaks of neighboring proton to n plus 1 multiplets. So if there is no proton on the side, so that means the signal will come as singlet. If there is one proton on the side, there will be two signal and we call it as a doublet. If there are two equivalent protons, then I will get a triplet. If there are three equivalent protons, they are called quartet. It's the normal notes, but I'm just writing quintet. Sextet, septet, octet, nonet. So this is how the signal splitting is driven. So I write CH3, CH2, C double bond O, O, CH, CH3, and there is a CH3. This is A, this is B, this is C, and these are D. So this is 3H proton. Its neighboring protons are 2. So 2 plus 1, 3H will be split as a triplet. So we write it 3H is a triplet. Then I go to B. There were 2 protons, so I wrote 2H. There were 3 protons which are splitting, so 3 plus 1, 4, so quartet. Then I go to proton C, 1H, surrounded by 6 equivalent protons. So 6 plus 1 equals 7, septet. Then 6H, because there were 3 protons here and 3 protons here, 3 plus 3 is 6, surrounded by only 1 proton, so 1 plus 1 is 2, a doublet. So when I look at the NMR of this is how the splitting of the peaks will be there. 3H will be a triplet, 2H will be a quartet, 1H will be a septet, and 6H will be a doublet. Now, which one will be most downfield out of A, B, C, D? Which one do you think is most downfield? C. That's right. C will be most downfield. This is A, this is B, this is C, this is D. So C is most downfield. Then is B. Then is D. And then is A. That's the order of chemical shift will be there. Yeah, of course, okay, I can do it again. Yeah. So I'm just writing again CH3, neighboring protons, 2 equivalent protons. So 3 protons, I wrote CH, 2 neighboring protons, so 2 plus 1, that means this 3H is going to be split into a triplet. And I told you in the class how the triplet. So one will be downfield, one will be uh, de-shielded, other is shielded, and another will be non-fact. So it will be kind of a this kind of a signal. Good? Till understood this point? Then I moved. What about these two H? I'm writing a different color so that you guys can see. Now I'm talking about these two H. I said, okay, what about you? Oh, we have three protons next to us. So 3 plus 1 is equal to 4. Those three protons are going to split our signal to quartet. Good. Then I wrote C double bond O O, and there was a C here with an H here, and CH3 and then CH3. Now you know that the three protons are same, which are six protons are same, these six. So I wrote 6H, and they were split by this proton. So 1 plus 1 equals to 2. So that will be a doublet. And then I saw that there was one proton here, which was surrounded by CH3 on this side and CH3 on this side. Basically, 6 protons plus 1 is 7. So I said 1H will be going to accept it. Clear? Got it? You? Everybody got it? Yes? Yes, of course. When I look at this compound, I saw that this is directly attached to an oxygen with carbonyl. So this is most downfield. Then I saw next is this one, CH2. So I said, this is next to a carbonyl, right? So this is most downfield. This is second one. Then between these six protons and this, they are closer to electronegative group. You see that? Oxygen is electronegative. So these two CH3 are closer to electronegative group, more closer to the electronegative group, more downfield. So I said these six protons will definitely more downfield than this CH3. And that's the conceptual understanding, right? More closer to the electronegative group, more downfield. Good? Understood? Okay. Now, let me just give you a few more, and now you guys are going to try. Let's do one this and one this and this. Okay. You have to write multiplicity of each proton. This question is the same. You can do this also. Okay, try these six. You have tried the multiplicity, and we'll do the ranking together. Giving you 5 minutes to think on your own, and then we'll do together, okay? Shall we start? Okay, waiting. Shall we start now? Everybody good? Awesome. Let's do it. Who's going to tell me the multiplicity? I'm writing like this so that we all have the correct answers. Who's going to tell me the multiplicity of the first one? 6H triplet and 2H doublet. Anybody with different answer? So look at CH3, all of you. And this is CH2. That's right. 3H singlet, sorry, 6H singlet. And 2H is also a singlet because I do not see any neighboring hydrogen next to it. So they will be all singlets. Perfectly correct. So I will just see in the NMR two signals, one with 2H, other with 6H, then the intensity of the signal. 2H will be more downfield, 6H will be not, but both will be, they both are downfield, right? But they will always be in the range of 3.5 to 4.5, but this will be more downfield than this one. Yeah. Yes, neighboring is the 1 to 3, 3 bond coupling. That's true. Perfectly correct. Good. That's right. 3 bonds away. So now next one. Who's going to tell me the next one? All triplets, 2H's. So let's see that. This is H, this is H. So perfectly correct answer. 2H is a triplet. There's another 2H with the triplet. There is another 2H with the triplet. Which is most downfield? A will be most downfield. Then B. And then C. So 3 2H triplets will be there. Right? So I'll see a triplet at more downfield. So this is A is most downfield. Where is quint? Oh, the quintet. Sorry. Yeah, the middle one is quintet, right? You're right. 2H is a. Oh, no. We are not doing quintet story today. So we are leaving this then, guys. No, we are not doing quintet story today. No, we leave it. We'll do it. We'll do it in the next time because we haven't talked about that. Depends upon coupling constant. Don't worry about it. Yeah, don't worry about that. Thank you for showing me that error. Like it is a good question, but we are not doing today because for that I have to explain you coupling constant very well. Okay, leave it. Okay, I was trying to be careful, but I think I just forgot. Okay, how many signals do you expect in this? Two singlets. Anybody else can tell me? Yes, all the H's are same. So all the H's are same. 4H singlet because it's symmetry. So simple one signal. No, there's no chemical environment different. When do they couple? When they are non-equivalent, right? That word, do not forget that word. Unless and until they're non, just sing that because that's the answer I'm giving you, right, Roshera? That only the non-equivalent protons can split. They're all equivalent protons. That's right. Right? That's why the word was non-equivalent protons. How many signals do you expect in 4? What is the multiplicity of each? Hmm? Do you think this proton is different from this proton? From this proton, it's completely symmetrical. 4H singlet. Two methyl groups. Yeah, of course, I can do three again. So CH3, CHCl, CH2, CH2, CH2. My question is the chemical environment of these two same or different? Same. If it is same, they are all equivalent. So equivalent protons do not couple. That's the logic I said. So the 4H will be just a singlet. Same story went on to the next one. I put two methyl groups on the ring. Complete symmetry, right? No, I didn't finish this. I was just finishing up when she asked me the question. Now there is another singlet which is 6H, which is a singlet. So there will be two singlets here. 4H. So there is A and there is B. Which is most downfield? 4H will be most. So A is greater than B.
Professor, I don't understand why is it a singlet?
Because they are exactly same.
Yeah, they're all the same, but they're surrounded by.
Surrounded by methyl, hydrogen, methyl, hydrogen, methyl, hydrogen, methyl, hydrogen.
Professor, I think the metal you're counting it as if there's no as if it's not having an effect. I think it's supposed to be for
No,
each
no, no.
quartet.
Hold on, hold on,
Okay.
hold on. Go slow. Here, go with me. One bond, two bond, three bond.
Oh, okay. Yeah. You're right. You're right.
I knew it. I knew it got messing then. One bond,
Oh, now I get
two
it.
bond, three bond. Got it? That's
Yes,
why I
thank you.
said 3J coupling. Because I know that students always start looking at others, so that's why I made very clear to them. After three bonds, stop. And that's your fourth bond, right?
So you should only worry about if three bonds away, there's another some forms of hydrogens there then.
Exactly, exactly. Just stop at three. That's it. After
Okay.
three bond, nothing is going to influence it. And especially when it is out of the ring, it will not influence at all. Benzene ring will only be influenced from the ring, only the ring. Never anything away out from the ring. Ever. Even if it's three bond, doesn't matter. Got it? So no. So that's why it is 4H singlet. And this 6H will be again a singlet. Which is more downfield? 4H will be more downfield. Why? Because benzene ring comes between 6.5 to 8.5. That's right. Three bonds means you count it like one, two, three. Hydrogen should be here.
Just to clarify, so the methyls on the benzene are singlets because three bonds away, there's no hydrogen
No,
there to
no,
affect it.
there is no neighboring hydrogen at all. Do you have any hydrogen? No.
Yeah. Okay. Just making sure. Thank you.
Good. Everybody got it? Everybody's getting the points? Okay. Now let's do five.
Just quickly for the last one, which one was more downfield?
The 4H one.
Okay.
Who's going to tell me five? So this is HA, but this is HB, right? And this is HC because the chemical environment changed. Now this will be a singlet This one gets split by this proton. So 1 plus 1, a doublet. Similarly, this one gets split by this. I'm showing you the color different. 1 plus 1, this is also a doublet. So you have a 2H doublet, another 2H doublet, and there is one H singlet. Now to talk about which is more downfield. Who can tell me that? We did this part in 307. Which of the two do you think is more downfield? Three. Don't worry about this. This one is singlet. Don't worry about this. Between HA and HB, which one do you think is? No, don't worry about C. C is a story different. Don't worry about the C part. I'm talking about benzene ring. Which of the two will be more downfield? A or B? B. Yes. If you remember that, I told you nitro is a withdrawing group. And withdrawing group means they are electronegative. So nitro is withdrawing because oxygen is pushing the electrons towards it. So this will be more downfield. Whereas OH on the ring is donating. And donating means releasing, donating, right? So this will make it upfield. Their range will be higher, but this will be more downfield than that of the withdrawal. Why isn't a triplet? There's only one hydrogen. I'm talking about 3J coupling, no? So 1, 2, 3. Why triplet? 1 plus 1 is only 2.
Do you not count the other HB since they're the same? So when
Where is HB? The HB is going far off. This HB will affect this one, this HB will. So that now what we can write is now, instead of writing 2, why did I write 2H? That's why I'm writing 2H, no? I'm talking about these two protons.
Okay, so if you used HA as like your 2, then wouldn't it be one from HB on the top and then one from HB on the bottom? So that
No. The 2H means the signal strength will be high, but it will be a doublet. 2H, when I say the 2H doublet, that means I'm talking about two equivalent protons, right? But they will be doublet. Each of them will be a doublet. They're not splitting each other.
Okay.
Got it? So this 2H is just telling you the intensity of that signal. Right? How many protons are responsible for that? Yes. Then the story completely different. Then we have another story to talk about.
So even though that both sides have an oxygen, because oxygen is more electronegative than nitrogen.
Because of the resonance withdrawing. This is a resonance withdrawing. So
Okay.
this is much more downfield.
If it was just a nitrogen, if you just had to choose between nitrogen and oxygen and not, you weren't able-
Then oxygen. Then oxygen.
oxygen.
Okay.
Okay.
I'll give you the example also. Suppose I'm giving you OH here and NH2 here. You see that?
Yeah.
Now the story is, now this one is whichever. You understood the point? So
Then the right side would be more. Okay.
Then let's do the last one, the CH3, CH2, which was this? CO, Cl, Cl, and CH3. No, I never said anything about OH. Don't worry about OH at this time. We'll talk about those story later on. Okay, who's going to tell me this one? This is A, this is B, this is C. Three H is a triplet. Okay. 2H is a quartet and 3H is a singlet. Which is most downfield? Which is most downfield? No. A lot of chlorines. Chlorine is more electronegative than carbon. C will be most downfield. Does not matter the C is to look. You have to see how many withdrawing groups are present. More the withdrawing groups present, more is downfield. C and then B and then A. That's right. So C will be most downfield, then B and then A. Now, every student should know how to draw resonating structures for phenol, aniline. I'm writing all the ones which you need to know. Ketone, nitro, if you do not know how to make resonance forms of these, you will struggle on to the example. In any case, definitely next lecture itself. Every student should, yeah, that's your homework. I always give homework in the office hours, guys. So that's your homework. Are you going to discuss? Of course, I'm going to discuss this. Right? We are going to start our story from here. So I want every one of you to make resonance forms of this. So draw all resonance forms for the compounds shown. That's homework question. Question 2. Um, what was I was thinking of? Oh, yeah. Draw the structures for the following compounds. Very important. Orthonitro benzoic acid, meta chloroaniline, para bromophenol, 3-chloro, 2-bromo, phenol. Oh, why should phenol? Toluene. Yes, next Friday. We start from here. That's how I end up my review sessions with you guys. So when I finish, I give you 1 or 2 homework problems. So you guys do those homework problems. Basically, I'm preparing it for the next office hours because I know that in the lectures, I'm going to review all part. Like we are going to talk about this. So you should not be saying, oh, what is she talking about? I already give you awareness that this is what we are going to talk. And this is going to be in the next part. You will be seeing that, oh, when I say withdrawing, donating, so you should know, oh, why she's talking donating and withdrawing, right? So when you make the resonance form, then we will go over. But okay, no hard feelings. If anybody is still struggling on these parts, Tuesday is the day. Come, we will make it together. So Tuesday you can say, okay, I could not make it. I do not know how to make it. Do not have conceptual understanding what's going on. So then I can help you how to make it. So I'll show you the conceptual understanding though we expect you to know from GenCam, Argo 1. But if you see that, oh no, I do not know how to make it, come Tuesday. Tuesday is your day where I just answer the questions from the students. So Tuesday, no new questions, no questions from my side. I don't bring any questions for you, because I feel that when I'm studying, when I'm doing something, I need somebody to help me why this is not there and why this is here. So Tuesday is just your day to ask the question. In that case, yeah, if any student say, oh, can you do one for me and explain me how does it work, I'll be more than happy to do that. Sounds good? Okay, that's all for today, guys. I think we have just finished till here, and I have given you all possible questions till here, and we'll continue a review next Friday, and you guys will have just go over everything. Come to me on Tuesday if you get any kind of help. You guys are most very welcome to see me. Sounds good? You guys are all very welcome. Have a great weekend, and I'll see you Tuesday. Okay, you're most welcome, guys. This is what is the first quiz on. Exactly, this is what we did. Like everything what I did in the lecture. That's it. And we will be doing a recitation. We all have recitation that day, right? Okay. Bye-bye. Huh.